Hi 13 Calculus. Welcome back to differentiation tutorials. Today we're talking about the equation of a tangent to the curve. So we're going to be talking about, well, what is the tangent to the curve? How can we find the equation of that tangent? And how can we check our answer on the graphics calculator? So here we go in your textbook. Find the equation of the tangent to the curve f of x equals 4 sine of 2x at x equals pi over 6. Well, let's talk about what tangent to the curve means briefly. So let's say we've got in this case, we've got a sine function. So if we pick a point on that function, let's say right here, the tangent to that curve is a line that goes right. It's not touching very well, but you get the idea. It's just touching that point at that, just at that x value. So what's happening here is that the gradient of that tangent is the same as the gradient of the function at that point. That's why these tangents are so useful in differential calculus, because at any point, the gradient of the tangent is the same as the gradient of the function. So let's go ahead and see if we can put that into action here with number 259. So if we're a tangent is a line, so to find the equation of this line, we need a point and we need the gradient. So let's start with the point. Well, here we have the x coordinate of the point, so we need the y coordinate. So all we got to do is just plug that x value in to the function, and that gives us y equals 4 times the sine of 2 times pi over 6. Well, that's just 4 times the sine of pi over 3. And this is why I have our unit circle in here. Where's pi over 3? Well, it's right up here. You might remember it as 60 degrees. And here's our right triangle. So we need the sine. Hopefully you remember that the ratio of sides in this 30, 60, 90 triangle is 1 here on the shorter side, 2 at the hypotenuse, and square root of 3 on the side which is opposite the pi over 3 or 60 degrees. So the sine, and this we're calling x. So the sine of this angle is the opposite, so that's square root of 3 over the hypotenuse, 2. So we're going to say 4 times square root of 3 over 2. Well, that's just 2 square root of 3. So our point is pi over 6 and 2 square root of 3. Okay, we got a point, so now we need the gradient. To find the gradient at that point, of course, we're going to find the gradient function first by finding f prime of x, or the derivative of the function. So the derivative of sine is cosine. So the derivative of this function is cosine of 2x. And hopefully, in the back of your mind, you've always got, do I need the chain rule? Well, with this argument, 2x, is that differentiable? It is. The derivative of 2x is 2. So I've got to multiply my coefficient right here, 4, multiply that by 2. So that gives us 8 cosine 2x. There's my gradient function. Now I want the value of this at a certain point. That point is pi over 6. So I've got f prime of pi over 6 equals 8 times the cosine of 2 times pi over 6. And that is the same as 8 times cosine of pi over 3. All right, back to the unit circle. Well, if the sine of pi over 3 is square root of 3 over 2, I hope you can see here that the cosine of that angle is 1/2. So what we have here is 8 times 1/2. So the gradient at pi over 6 is 4. So we've got a point and we've got a gradient. We're ready to plug those into our point gradient formula, which hopefully you remember. It looks like this. Y minus y1 equals m times x minus x1. And now we'll just plug in everything we have here. So that's y minus 2 square root of 3 equals 4 times x minus pi over 6. And let's tidy this up. We could say y equals 4x minus 4 pi over 6 plus 2 square root of 3. Now let's go to the calculator and evaluate all these constant terms. So we've got minus 4 times pi divided by 6 plus 2 times the square root of 3. And that's giving us 1.3697. So our answer is y equals 4x plus 1.3697. Great. Now, if you'd like, you can check that on the graphics calculator. I'm going to show you how to do that right now. So what we've got to do is go to the graphing menu. So hit menu and scroll down to graph, enter, and then you're going to type in your original function, which is 4 times the sine of 2x. Enter that. And then let's have a look. There it is. That looks like a sine wave to me. So now we are wanting to know the equation of the tangent at pi over 6. So if you hit F4, that's going to give us some options here. So here we go. And you can see one of them, the F2 option, is tangent. So you're going to hit F2 for tangent. Now that's just going to land you at a point in the middle of your window, and which is probably not where you want it. So you can cursor back, or you can cursor forward to the point you want, but the easiest way to get to the point you want is to just enter the value. So we'll just enter pi divided by 6, enter, and that will move your cursor right to that point on the graph. And you can see we have coordinates and we have the gradient at that point, which is 4. Well, that's good. That's what we thought our gradient was at pi over 6. Now, if you want to, if you just hit enter again, it's going to display the tangent at that point, as well as the equation for the tangent. So here's the tangent, and then it's saying that the equation of the tangent right underneath here is y equals 4x plus 1.3697. So you've just checked your answer on the graphics calculator, and you're all set. I will see you in class 13 Calc. Later.